Now let's see the different methods of removing hardness. Now first let's see the method for removing temporary hardness. Temporary hardness can be removed either by boiling the water or by adding lime. Now first one is boiling. So calcium carbonate, which is slightly soluble, generally exists in the water in the form of calcium bicarbonate, because calcium bicarbonate easily dissolves in the natural water containing carbon dioxide. Now therefore, when you boil the water and the carbon dioxide gas is driven out, once again the calcium bicarbonate gets converted into calcium carbonate, which is insoluble in the water, which cannot dissolve in the water, hence it precipitates as calcium carbonate, and this can be sedimented out in a settling tank. The same thing is shown in an equation, chemical equation form here. Calcium bicarbonate, which is readily dissolved in the water or which is soluble in the water, and you are heating that water, the carbon dioxide gas goes away and the calcium carbonate, which is an insoluble precipitate, gets deposited. So that is how the temporary hardness is removed from the water. So these calcium salts, which are going to give hardness to the water, they get precipitated. That is how it gets removed, right? Now there is one problem with this boiling is the magnesium bicarbonate and magnesium carbonate cannot be satisfactorily removed by using this method, as the magnesium carbonate is fairly soluble in the water, and boiling therefore cannot remove the temporary hardness caused by magnesium, right? So this is one disadvantage with this method. Now addition of lime is another method of removing the temporary hardness. So calcium oxide or lime, which is generally added in the form of hydrated lime, that is calcium hydroxide, that is added in the water, and again you have to write the chemical equations. So these are all purely chemical methods, and the chemical reaction between the salt which you are adding in the water and the hardness causing salts in the water. So you have to show them in the chemical equation, and the soluble minerals in the water which are imparting hardness in the water, they are converted into insoluble precipitates. So what is dissolved in the water, you are converting into an insoluble precipitate, so it will precipitate, and that is how the hardness is reduced or it is removed, right? So that is why everywhere you have to write these chemical equations. Now magnesium carbonate, which is soluble, magnesium bicarbonate, which is soluble in the water, then calcium bicarbonate, which is soluble in the water, all of these three are going to cause hardness in the water, and you are adding hydrated lime or the calcium hydroxide. So magnesium carbonate and calcium hydroxide react together, and magnesium hydroxide and calcium carbonate is produced. Both are insoluble precipitate, so they can be easily settled out. Similarly, magnesium bicarbonate reacts with calcium hydroxide, and calcium bicarbonate and magnesium hydroxide is produced. And this calcium bicarbonate is going to once again react with the lime or the calcium hydroxide, and it once again gets converted into calcium carbonate. So this also is precipitated. Now in all these three equations, you can see the calcium carbonate and magnesium hydroxide, these are produced after completing the equation, chemical reaction. These two are produced, and both of them are not soluble in the water or not easily soluble in the water, therefore can be precipitated and removed in a sedimentation tank, right? Next is methods of removing permanent hardness. There are three methods: lime soda process, base exchange, generally known as the zeolite softener or zeolite process, and demineralization process. So in your syllabus they are given lime soda process and the zeolite process. So let's see those two. So lime soda process for removing the hardness: calcium hydroxide and sodium carbonate or soda ash, lime or soda ash, right? So lime and soda ash, these are added in the hard water, and these two are going to react with the calcium and magnesium salts to again form insoluble precipitate of calcium carbonate and magnesium hydroxide. Same thing what you have seen here, calcium carbonate and magnesium hydroxide. So here also these are produced and these are precipitated in a sedimentation tank. So lime soda process also, you can see here calcium bicarbonate, magnesium bicarbonate, these are salts which are causing temporary hardness. They are going to react with lime, calcium hydroxide, and calcium carbonate is produced, magnesium hydroxide is produced. These are all insoluble precipitates, right? Then similarly, magnesium carbonate is going to react with lime and magnesium hydroxide is produced, that is also going to get precipitated. Similarly, calcium carbonate is produced, that is also insoluble and hence it precipitates. Now there are permanent hardness causing salts like magnesium chloride, magnesium sulfate, calcium chloride, calcium sulfate, right? So now this magnesium chloride and magnesium sulfate, they can react with lime, and once again magnesium hydroxide precipitate is produced. And in both the cases you will find that some salts which are causing non-carbonate hardness or a permanent hardness, they are produced here, calcium chloride and calcium sulfate. So these two are going to again impart permanent hardness in the water. So now they are non-carbonate hardness producing salts. Now those are going to react with the sodium carbonate, and once again calcium carbonate is produced, which is an insoluble precipitate. So this is how all the temporary and permanent hardness causing salts, both non-carbonate and carbonate hardness causing salts, everything is removed. See here, carbonate hardness, that is magnesium chloride and magnesium bicarbonate, calcium bicarbonate, these are all carbonate hardness causing salts, while as magnesium chloride and then calcium chloride, magnesium sulfate, calcium sulfate, these are non-carbonate or permanent hardness causing salts. So all of them get converted into either calcium chloride or magnesium hydroxide, right? These two are insoluble precipitates, they cannot dissolve in the water, so they get precipitated. So that is how they are removed from the water. So the clear water you remove, and whatever precipitate has settled down, that you can remove later. Now most of the calcium carbonate and magnesium hydroxide which is formed in those equations you have seen, they can easily get precipitated and sedimented out in a sedimentation tank. Now however, a small quantity of these insoluble precipitate of calcium carbonate and magnesium hydroxide, they remain as finely divided particles and may cause trouble by getting deposited on the filter in the filter tank, right? And they may also get deposited in pipes of the distribution system. So therefore, to prevent this from happening, it is necessary that the water has to be it has to undergo a process called as recarbonization. So recarbonation is done by passing carbon dioxide gas through the water when it leaves the sedimentation tank. So as the softened water leaves the sedimentation tank, you have to recarbonate it by passing carbon dioxide. So in this process, the insoluble carbonates which are combining with the carbon dioxide again, here you can see in the equation, the calcium carbonate, which is an insoluble precipitate which is removed after the softening treatment, you are passing carbon dioxide in the water and it is once again converted into insoluble calcium bicarbonate. And similarly, magnesium hydroxide, which is an insoluble precipitate which is removed after softening magnesium hydroxide, it is going to react with the carbon dioxide and it is going to get converted into magnesium carbonate. This magnesium carbonate once again reacts with the carbon dioxide gas and gets converted into magnesium bicarbonate, right? So in this process, the calcium bicarbonate and magnesium bicarbonate which is produced, they are soluble and they can easily get dissolved in the water. So therefore, by the recarbonation process, the water gains some of its hardness, but it is not a problem because the amount of the calcium carbonate and the magnesium carbonate and the magnesium hydroxide which is remaining in the water after softening is very less when it comes out of the sedimentation tank, because most of the precipitates are removed in the sedimentation tank and whatever little is left, as you can see here, finely divided particles. A very small quantity, a little quantity will remain as finely divided particles. So only that small quantity which is remaining as a finely divided particle, only that much is going to once again get converted into soluble calcium bicarbonate, magnesium bicarbonate and magnesium carbonate. So a little amount of hardness is once again given back to the water. So water regains some of the hardness after the recarbonization is done, but still it is always advisable because it will avoid problem later on in the distribution system and in the filters. So you have to always recarbonate the water. Now the lime soda process is widely used and it has got the following advantages. The process is economical. It can be easily combined with the usual water treatment methods without any extra cost or extra trouble. When lime and soda are added in addition to the coagulants during the process of softening and coagulation, less amount of coagulant is generally required, right? So the chemical requirement in a coagulation tank would be less. This treatment leads to a slight increase in the pH value of the water, thus reducing the corrosive property of the water. Then the increased causticity may also sometimes help in killing pathogenic bacteria. This lime also helps in killing some pathogenic organisms, and because of the increase in the pH value. This treatment helps in reducing the total mineral content of the water. So overall the mineral content will be less. It also helps in removing iron and manganese from the water to some extent. So these are some of the advantages, and there are some limitations and disadvantages also. The most important disadvantage is the large quantity of sludge which is developed. That is, the sludge is what? The insoluble precipitate of calcium carbonate and magnesium hydroxide. A large quantity of this is produced, and it has to be, proper arrangement has to be made for disposal of this large quantity of sludge. So this is the important disadvantage, right? So we will see the zeolite softener in the next video.